In this video, we'll demonstrate how to set up the equipment that we use to study cardiac muscle contraction and also how to get a first response. Here we have two Palmer stands. To the left one is attached the force transducer, and to the right one are attached a set of curved forceps which are themselves attached to a set of micromanipulators. We also have a tissue bath into which we will be placing our heart muscle, and this is sitting on a stand inside a petri dish, and the whole apparatus is on an adjustable platform. We also have a set of gas taps which supply carbogen, which we then bubble through the solutions that our heart muscle is sitting in. And on the bench we also have some pasta pipettes, some curved forceps, and two 5mm syringes with tubes attached for changing solutions later on. This piece of equipment here is the control board for the force transducer. We use the dial on the left for zeroing the output of the force transducer and the switch on the right for setting the range of the force transducer. We have the force transducer plugged into input 1 of the power lab, and we have an output going from the positive terminal of the power lab to the stimulating electrodes on the tissue bath. Now, to set up our muscle, we'll be tying the muscle on the very tips of the wire from the force transducer and the curved forceps, and we want the muscle to sit as low as possible so it can be dipped effectively into the tissue bath. The dials on the tops of the Palmer stands allow us to adjust the forceps up and down so that the tips of the forceps are level with the tip of the wire from the force transducer. So once you've got everything in position, you then take your muscle strip from the normal ringers that you had it bubbling in. There is a piece of cotton tied down one end of the muscle strip, and so you make a loop using that piece of cotton, and that's what we tie to the force transducer, as you can see being done here. Once you've got that first loop tied to the force transducer, we then do another one, so we do a double knot, and that just holds the muscle on tightly. Next, we use the curved forceps from our bench and grab the other end of the muscle strip, and we want to stretch that muscle strip so that it can be grasped in the curved ends of the forceps attached to the right-hand Palmer stand. And now our muscle is clamped firmly in the forceps, and the other end is attached to the force transducer, and so we can measure the amount of force generated by that strip of muscle. Once that's done, we can wind up the platform on which the tissue bath is sitting, and so we immerse our heart muscle into the tissue bath. Now you may need to adjust the carbogen flow so that the bubbles aren't too vigorous, otherwise they tend to splash the solution everywhere. And lastly, if you ever need to stretch the muscle, which we'll talk about in just a moment, you can use these micromanipulators to either push or pull the forceps closer to or further away from the force transducer. And so now we've got our muscle all set up, so let's go across to the lab chart window and have a look at what we've got there. Now that we've got our muscle in, we'll click Start, and that will stimulate the muscle and then record a response for 5 seconds. And our lab chart stopped recording, as you can tell by the stop button turning back into the start button, and also on this document tab, the little icon at the start of it changes into a solid yellow circle after it's finished. But we can't see a response, so our response is somewhere off screen. So we'll just click the auto scale button, and that will bring everything back onto our screen for us. And that looks like a really nice response, so the amplitude is nice and high, well above the baseline. If you mouse over the left axis until you get a double-headed arrow, you can slide the whole trace up and down. If you move your cursor up until you get a single-headed arrow, you can stretch and contract the y-axis so you can make your trace taller or shorter. Now imagine we had a response like this, which is much smaller. So let's measure the height of this response. We'll put the marker on the baseline and put our cursor over the peak, and then reading in the top right-hand corner, you can see the amplitude of this response. And here we're getting something in the order of 0.872 millinewtons, which is quite small. Now we want to make sure that we're getting a reasonable size response so that we can examine experimental parameters which both increase or decrease the size of the response. So let's make this response a little bit bigger by increasing the length of the muscle. And you'll recall from last year that increasing the length of the muscle helps to optimize the overlap of the thick and thin filaments, thereby increasing the tension that can be developed by the muscle. Heart muscle works in the same way, so we'll try that here. And now we'll click Start. And if we add back an overlay of the previous response, you can see that we now have a much larger response compared to what we had before, which is really good. If we pop the marker back over the baseline and put our cursor over the peak of the amplitude, we can see that we're getting something in the order of 2.652 millinewtons now. So definitely much bigger than we were getting before. I think we can go a little bit bigger, but before we do that, let me just show you one other thing that we're doing off screen. Every time we take a recording, we're actually stopping the flow of gas to the tissue bath so that there's no bubbles jostling the muscle during the actual recording. If you take a closer look, you can see the bubbles are buffeting against the muscle quite a lot, and the force transducer is extremely sensitive, and so those bubbles bumping against the muscle gets picked up by the force transducer. So for the 5 seconds while a recording is being made, we just stop the bubbles as shown here, and then you get a nice clean trace. This is what a trace looks like if you forget to stop the bubbles, and you can see all these bumps throughout the duration of the recording. And this is the next trace in that same preparation 30 seconds later, where we remembered to stop the gas, and you can see that the recording is much smoother. Right, so now if we go back to our muscle, so let's put a little bit more tension in it and let's try again. And here when we measure the amplitude of this trace, we get 3.543 millinewtons. So again, much bigger. Now, the amount of force that a muscle can generate will depend on the cross-sectional area of the muscle. So if you've got a really big muscle strip, then you can get up to 8 or even 14 millinewtons. This is a relatively small strip, and we're getting a really nice trace here. So 3.5 millinewtons is fine for what we're after. Right, now during the experimental portion of the practical, you'll be using 2 different macros in order to stimulate the muscle at various frequencies. Those macros can be accessed from 2 places. Firstly, from these 2 buttons here. The first button is for a macro that stimulates the muscle every 30 seconds. The second macro also stimulates once every 30 seconds initially, but then abruptly changes to stimulating once every 5 seconds. And we use that in one of the activities, which we'll talk about at that time. The second place that you can access the macros is through this macro menu. If you click on that, you can see the 2 macros down the bottom. Let me just select that first one. And so now the software will stimulate the muscle once every 30 seconds, and you can see a countdown timer here. This dialog box here shows the stimulus that you're delivering, and here we're giving a stimulus of 10 volts. For a duration of 10 milliseconds. Now if you have a look at your notes, once you've got your equipment set up and you've managed to capture a response, your notes ask you to paste a screen capture of a typical cardiac muscle twitch here in your notes and then label the following. Now if you're performing this practical at home, then unfortunately you haven't had access to the equipment, but we will have supplied you with several data files for each of the activities. And so to carry out this first step, just choose one of the data files and any of them will do. So I've just opened up the first one here. And so let's get rid of the overlay so that we're only looking at one of the traces, which is what the notes ask you for. And then just have a flick through those traces and just try to find a nice even trace, which is sort of like the ones that we've been looking at here. And then using those notes, label each of the parameters that they ask you for.